Okay, this is 6.4 homework calc. The first problem tells us we have an angle between negative 90 and 90, and it wants us to find polar coordinates between those angles that have the following rectangular coordinates. So, the first one I'm going to graph 18, comma negative 7. That point is down here. I'm going to make a right triangle here, call this 18, call this negative 7. And then what they want us to find is r and theta to convert this into polar. So, and they wanted a negative angle here because they want it between negative 90 and 90. So, to find that, I'm going to do inverse tangent of opposite over adjacent. That gives you my angle. Make sure you're in radian mode. And that gives you about negative 0.371 radians. So it's r theta, so theta goes second, negative 0.371. And then the r value is the square root of 373, because that's the Pythagorean theorem to find this length right here. So just give the r theta, set up your triangle, and find theta by doing inverse tangent, and then find r by doing the Pythagorean theorem. It should be the same for the rest of them. Okay, the next problem 2 says convert the following polar coordinates into rectangular. So this polar coordinate that I have right here goes 45 degrees, so I'm going to rotate 45 degrees, which is along this line, and then it goes out 2 units. So there's the polar coordinate right there. Now, if I write this angle pi over 4 right there, what I'm looking for is x and y. So I'm going to find x and y right here. Now I can do that with special right triangles. So you can obviously use sine and cosine as well. But I think the easiest way is to use your special right triangle values for this one, which is if this is like s, this is s, this is s squared root of 2. Therefore, s is 2 divided by the square root of 2. If you set these equal. And therefore, that's what x is as well. So that means I go over 2 divided by the square root of 2, and then I go up 2 divided by the square root of 2. Okay, the next problem, it says for each set of polar coordinates, we want the rectangular Cartesian coordinates. So I'll just do the first one here. The first one, we rotate around negative 7 pi over 3. So 3 goes into 7 2 times, leaving a remainder of 1. So it's 1 2/3, but it's negative. So negative 2, negative 2 1/3 pi. So I go back around 2 pi plus a negative third pi, which is 60 degrees right here. So there's pi over 3 negative. And then I need to go back negative 5. So I'm actually going to go back in this direction, where this would now be the 60-degree angle, or the pi over 3, because they're vertical angles right here. So then this length would be 5 out to this point. So that's the point I'm looking at, and I can then do the rectangular coordinates x and y. Actually, the special right triangle I think is the way to go, because you could do s. This would be whatever the small leg is times the square root of 3, and this would be 2s. So therefore s is 5 halves. So this is 5 halves, and this would be then 5 halves square root of 3. Now this does need to be negative. So negative 2.5 and then 2.5 square root of 3 is the exact same thing as we have here when we go back 2.5 and then up 5 halves square root of 3. Okay, the next problem gives us an equation, a polar coordinate equation. R varies in terms of theta. And it says point P is at this angle. And it says find the polar coordinates of point P for a positive R value and an angle between 180 and 270. So I'm going to first find R by plugging in this 22. And by the way, this simplifies. Mine simplifies to 11 pi over 9. So we're just going to plug in 11 pi over 9 in my calculator and make sure I'm in radian mode. And that's going to give me an R value. And R value is 5.936 approximately. And next we're going to find the Cartesian coordinates for P. So let me just graph this real quick. We're going around 11 pi over 9. So 9 goes into 11 one time with a remainder of 2. So it's 1 2/9. So it's over 1 pi plus 2/9. So this would be 2/9 radians. And our R value in this case is 5.936. So I want to find x and y. So all I need to do is use cosine and sine. Cosine of 2/9 radians equals adjacent over hypotenuse, and I'm not going to round this number, I'm going to keep it in my calculator. And I'm also going to do sine of 2/9 equals y over 5.936. Now I want to multiply both sides by 5.36 in each of these cases. It gives me x and y. And I get these numbers here. They both have to be negative because I'm going back down here into the third quadrant. So I got to go back x and then down y. And then it says how many times did the curve pass through the origin? The answer to that is 0. If it passes through the origin, what would need to happen is I would need to get r to be 0. So when you plug this in right here, where does r equal 0? And you can look for that angle where that happens, but there's no place where that happens because when you subtract 9 and divide both sides by 4, you get a number here that's bigger than 1. You know, it's 2 and with a remainder of 1/4, so negative 2 1/4. Cosine never gets that big. Cosine only gets to negative 1 and 1. So unfortunately, there's no angle where I get an r of 0. And you can graph this in your calculator as well. If you type this in and your calculator, you want to go to polar mode. So hit mode and scroll over to polar here. And then your y equals, you're just going to enter this in. So make sure my plot's turned off here. So this is 9 plus 4 cosine of theta, and you can graph this, and you might want to change the window a little bit, but you can see it's basically an ellipse, and it never goes through the origin. Okay, the next problem says the side of the points are given in polar coordinates are the same, true or false. So you just quickly graph both of these. This one rotates 30 degrees, pi over 3, and goes out 5 right here. This next one rotates back 30 degrees. This would be pi over 3 here. It rotates, but goes back 5, so it'll go back this direction. Those are definitely not the same points. This point and this point are definitely not the same, so I would say false. You can just follow that same process for the rest of these. All right, the next problem says you're given a point 1 and 90 degrees in polar coordinates. It wants you to find another pair of polar coordinates where r is positive and the angle is between 2 pi and 4 pi. So we're going to graph this. This is 90 degrees and it goes up 1. We're talking about this point right here. We're going to find another pair here where the angle is between 2 pi and 4 pi. So I would need to go around 2 pi, and I would actually need to go to this point down here, which would be 3 pi, and then go back 1. So my theta would be 3 pi, but I want to go back 1, so that I rotate around once, all the way around once, and then around another 3/2 pi. Actually, then I've got this wrong. I'd want to go around 3 pi, which would take me 2, 3, take me to here, and I'd need to go this extra pi over 2. So I'm going to add pi over 2 to 3 pi. Get a common denominator, and multiply top and bottom by 2. That'd be 7 pi over 2. So I actually want 7 pi over 2 in order to get me down to this point down here. And then to go back up, I would use the negative 1 right there. So that should work just fine. And we can do the same process for the rest of them. Okay, for the next problem, I'm going to go through this a little quickly if you guys don't mind. You want to graph both these polar coordinates. So the first one has a hypotenuse of 1 here, and it goes over 30 degrees. And so, you know, this would be s, this would be s squared root of 3, and this would be 2s. S is 1/2 in this case, so this becomes square root of 3 over 2. And this is just s, so that's just 1/2, so therefore there's my coordinates right there. Next one, the same thing when I go back, and this is a 45, 45, 90 triangle, so this would be s, s, and s squared root of 2. And since the hypotenuse in this case is 3, I have 3 divided by the square root of 2 for these coordinates, and I need to go back and up 3 square root of 2. So here's my rectangular coordinates. Now I can just use the distance formula between them. The distance formula is right here, as you remember, difference of the y squared plus difference of the x squared, square rooted. So I plug everything in and just evaluate my calculator, and I end up getting about 3.399. All right, next problem then, the last problem, it gives us Cartesian coordinates. It says we're going to go back 1 and down negative square root of 3. So we're looking at this here, where this is 1, this is negative square root of 3. Now you might recognize these values. That makes this a 30, 60, 90, where this would be 60, this would be 30. And the hypotenuse would be 2 in this case. This is also back 1, I'm sorry. So we've got a 30 to 69 triangle. This is s squared root of 3, and this is 2s. You can see the relationships here. Now it says find polar coordinates where r is positive and the angle is between 0 and 2 pi. So the angle we want to rotate is around pi plus pi over 3. So pi plus pi over 3, that's 180 plus 60. Let's get a common denominator. It's 4 pi over 3. And you might remember that from the unit circle. And then I just need to go out the distance of 2 that we had for this hypotenuse right here. All right, I hope this helps.